Well, welcome everyone. My name is Fernando Freire. I'm a staff engineer here at Armory. We are one of the companies that is developing Spinnaker at the enterprise level. And I'm here to show you today how you can become a contributor yourself to the Spinnaker project. There are a number of different ways that you can develop against Spinnaker. So we're going to show you kind of the way that we do things here at Armory. And hopefully that helps accelerate your development workflow when you're working either on Spinnaker directly or adding functionality for your own organization. Now, I know it can appear challenging to develop against Spinnaker, but the goal of this workshop today is to demystify all of the moving components of Spinnaker so that you have the tools to implement whatever functionality you need or your organization needs. So we're going to cover a lot of material today, which is totally fine. If you walk away not understanding 100% of the material, that just means you're a human being. And you know, we have a list of notes that you can follow through after the workshop if you want to come back to anything afterwards. So we're going to go ahead and share all of those links in the chat. They should already be here. So that first link is going to be the workshop notes. That's going to follow all the that's going to go through all of the tasks that we're going to be going through today. And then a couple of links for some repositories that we're going to look at first. So I'm going to go ahead and move over to our window here. So this first link, the workshop notes, again, that just walks through everything that we're going to be working on today. Hopefully, as a prerequisite, you have some of these tools already installed. So today we're going to be using IntelliJ to modify some of the backend services, and we're going to be using VI to modify Deck, which is the front-end UI service. But you can choose whatever editor you want. This workshop notes just assumes for the whole time that you're going to be using IntelliJ. You also want to have JDK 11 on your machine, Yarn for building Deck and running the Deck project, kubectl for working with the Kubernetes cluster, and then Telepresence, which is a tool that you may not exactly be familiar with, but we'll show you how it works today. And then Spinnaker 122X. I know earlier this morning you might have seen a message from me that we released 123. So just to make sure that we don't run into any surprises, we'll stick with 122 for today. And if you find that 123 works for you after the workshop, then go ahead and continue using that so you can take advantage of all the goodies that we just released. Now, you don't have to do anything to have Spinnaker 122 in your cluster. We already have the Spinnaker operator running in the clusters. So you'll just have to create a config that you will then apply cluster. So with that in mind, I'm going to show you what we're going to have completed at the end of this workshop if all goes to plan. So I'm going to switch over here, and I've got a local development environment. So what you're seeing here is the Spinnaker UI. So a lot of this, if you have taken a brief hiatus from Spinnaker, this might look a little bit different. What we've done here is we've actually redesigned the application overview, and this is a change that we've made this application overview page a little bit easier to do and make a little bit better use of screen real estate here. So what we're going to do is we're going to have an application. Today it's just going to be a demo application, and we're going to be adding a new stage to Spinnaker. So if you go into the pipeline configuration here, you can see that I have my stage here. It's a totally brand new stage. It doesn't do anything useful, but that's all right. And then when we go ahead and run this stage execution, we'll see it has started here. It's succeeded, and then we've got some sample message here. So this is a stage that's not part of the core Spinnaker project. We're going to go ahead and make some modifications to Orca, the backend service that we'll be working with today to kind of enable this to work through it. So in order to be successful, we're going to need to clone a few projects, and they're going to take a little bit of time. So I'm putting these links, the links already in the chat here, and the links already in the chat here for Orca and Deck. So go ahead and go to Orca, go to Deck, and then click on this code button right here, and then click on the clone URL that you get here and clone it to your local machine. I've already got these projects cloned, so I'll just go ahead and show you. Let's see, I'll go ahead and show you what they look like here. So if it's successful, you'll probably see this Spinnaker Deck remote here, and then a whole bunch of files here, right? So that'll tell you that you've cloned everything successfully. So why don't you go ahead and start cloning Orca and Deck, and since that'll take a little bit of time, we will move over to asking a few questions just to kind of gauge the room and everyone's level of experience. So I'm going to go ahead and pause sharing so that you all can see this link on the screen here. So if you can go ahead and go to Slido and then this hashtag or use this QR code, I'm going to go ahead and start the poll. And I'm curious to know, everybody who's on the call today, where are you joining us from? Myself, I am based out of Portland, Oregon. So if you are not familiar with United States geography, that's okay. We are in the upper left part of the United States. We're in the Pacific time zone, and it is currently chilly. I don't know, it's turning into fall. The trees are red. So if you want to share where you're joining us from today, that'll be great. And we'll give you a moment to respond there. All right, so it looks like we have our first respondent. We have some folks joining us from Seattle. So that's not too far away from us, just a few hours north. All right, that's all right. Let's go ahead and move on to the next question then. These questions are a little bit more important. These are going to help me gauge the content correctly for you all today and make sure that you get the most out of this session. So the next question that we have on the screen here is, how familiar are you with Spinnaker? You know it's a boat. That's technically correct, but we're going to be talking about the continuous delivery tool today. I've interacted with it as a user, maybe as a part of your organization, or if you've kind of messed around with it on your own. You've submitted a pull request or two, or you're a frequent contributor. And there are no wrong answers here. This is just to help me figure out what level of detail we want to talk about things today. Excellent. So it looks like some of you have used Spinnaker as a user. So that's great. You're going to get some really meaty knowledge today working with some of Spinnaker's services under the hood. All right, and then the last question that we're going to ask today is, how familiar are you with Kubernetes? So one, I know my Greek, how dare you? Yeah, Kubernetes, I guess, is like sort of Greek for helmsman or a pilot, like on a boat. You've used Kubernetes in the past, that's great. I actively use Kubernetes for my work, that's even better. And I have 20 years of Kubernetes experience. I know you're lying, but you'll give me a chuckle, I guess. All right, and it looks like some of you are actively using Kubernetes for your work, so that's great. We won't have to spend a ton of time talking about the Spinnaker operator then. So why don't we go ahead and move on to the next part of our session. So let's spend a little bit of time talking at a high level about some of the technologies that we're going to be using today. And we're going to first start off with a diagram of Spinnaker architecture. Now, I know this can look like a little bit of an eye chart, but really what we're looking at here is a set of services. We've got about 10 microservices that are in use here in the core Spinnaker project. And then you've got two different ways of working with Spinnaker itself. And I'm going to go ahead and resume my sharing so you can actually see what I'm talking about. So on the far left-hand side, you have these two tools, Halyard and Operator, for managing your Spinnaker configuration. And then in the center here, you've got your core Spinnaker services. And then kind of at the periphery, you have all of the different integrations that you can add to Spinnaker to make it useful within the context of your organization. So if you've been a part of Spinnaker development for a while now, you'll know that Halyard is kind of the de facto tool for configuring and administering your Spinnaker cluster. And Halyard is a mature tool, but it covers a wide range of use cases right, that stop more or less at configuration. They don't kind of help you manage the life cycle of a cluster based on events that are happening inside of Kubernetes. So for those of you that responded to using Kubernetes at your work, great. You are no doubt familiar with operator or the concept of operators. And so what we've done here at Armory is we've built open source Spinnaker operator and a proprietary operator that we will not be using today. We'll be sticking to the open source side of things that helps you manage the lifecycle of Spinnaker within your cluster. So it can do things like create configuration using Halyard under the hood at this time. And it can also modify pod settings. For example, you need to increase resource allocation for your cloud driver pod, or you need to expose your Spinnaker to the World Wide Web. You can use the operator to automatically identify some of those items so that you don't have to manually configure every little thing and understand how to configure Spinnaker down to the minutest detail. Now, if you're less familiar with Spinnaker, we're going to walk through some of these core services just at a very 9,000 foot view so that we kind of have a rough idea of what all these services are doing. So I'm going to go from the top left and I'm going to go each row left to right and then top down. So starting in the top left, we have Deck. Deck is the service that we're going to be using today to modify the user interface. And it's currently written in a mix of React and Angular 1. And otherwise is just like a regular TypeScript project. Then we have Gate. Gate is the front door for all API calls in the Spinnaker ecosystem. It's going to kind of sit at the edge. Deck is going to be talking to Gate. Other API callers are going to be talking to Gate, and then Gate will kind of forward everything else to you as your services within the cluster. Next, we have Igor. Igor is the service that is responsible for interfacing with CI systems and kind of ferrying build event notifications to Echo, or just kind of caching build results from your CI systems like Jenkins and Docker, and making sure that all that information is provided to other services within the system. Now in the second row on the far left, we have Kyenta. Kyenta is the automated canary analysis service for Spinnaker. So once you get into more advanced continuous delivery workflows, Kyenta is going to be the service that is going to help you analyze all of your data from Prometheus, from Datadog, from New Relic, from whatever metrics provider you want to bring to the table and integrate with Kyenta. And it'll kind of give you a common framework for building these automated canary use cases where you can determine whether your newly deployed service is healthy versus not. Now, next one over to your right is going to be the Orca service. So Orca is also one of the services that we're going to be working with today. And Orca is the orchestration layer for Spinnaker. So all tasks within the cluster are going to be managed and distributed using the Orca service. And so this is the service that we're going to be using to add a new task for our custom stage. And then we'll be modifying Deck to expose that stage in the UI. Then the next one that we have is Echo. Echo is kind of the event router for everything in the cluster. So it's going to interact with a lot of these systems to kind of distribute messages. If Igor is notified of a build finishing, it's going to send it to Echo, and then Echo is responsible for kind of shuttling that out to whatever service needs to consume that message or needs to know about it. And finally, last one in the second row, we have Fiat. Fiat is kind of the auth-in, auth-c service that you have in the cluster. So it's going to integrate with your SAML provider to provide authentication to the cluster, and then provide some auth-c mechanism for service-to-service calls. Then finally, on the last row, we have 3 left. I know there's a lot of services here. But on the last row, far left, we have Roscoe. Roscoe is considered the bakery for Spinnaker. So if you are deploying to EC2 and you're baking an AMI, for example, or if you're baking a customized manifest or a Helm manifest that you're then going to deploy into your cluster, Roscoe is kind of the service that will help that use case for you. Now I'm noticing in the chat, so Echo acts like PubSub in a similar way. Yes, it's not implementing like a true queuing system, but it is acting as that kind of PubSub mechanism for Spinnaker itself. Finally, in the last row, we have Cloud Driver in the middle. Cloud Driver is that cloud abstraction layer. So if you want to implement a consistent API across AWS, Azure, GCP, Kubernetes, Cloud Driver is the service that is going to be giving you that consistent interface. So this is the service that really allows that multi-cloud deployment target that Spinnaker gives you. And Cloud Driver is the engine that powers everything. And then finally, on the last row, farthest to the right, we have Front 50. Front 50 is the service that's going to be interacting with all these different storage layers. So we'll actually see this when we're configuring Spinnaker and installing it in the cluster. We're actually not going to be using S3 today. We're going to be using an S3 compatible object store called Minio. And Minio is going to give us the same kind of key value store that we would use if we were using S3, so that we can keep everything self-contained to the cluster. So I know this has been a lot of information. One thing that I'll call out is there is a recording here posted from a previous workshop. We talked through very similar concepts at this high-level architecture diagram. So if you want to review this later at a slower pace, please do check out that video and come back with questions either in the Gardening Days channel or feel free to reach out on Slack, and we'll get you sorted. So that's about it as far as architecture. So we are going to move on to the next stage here. So hopefully by now you have successfully cloned Orca and Deck. Please let me know if you haven't in the chat, and we'll do our best to kind of help you out there. Otherwise, we're going to move on to the next repository that we're going to be talking about today. This repository is called Spinnaker Customized Patches. This is a repository that we provide with a number of different recipes for getting started with using the Spinnaker operator. So this is going to talk about, at a high level, what this repository is providing for you and kind of how you can get it going. But really, all you need to know for right now is click on this big green button here that says use this template. Of course, it's going to ask me to authenticate with my single sign-on provider. Great. So then it's going to give me this option to create a new repository name. I'm going to call it 2020 Spinnaker Summit, which is a repository that I already have. So I'm just going to call this 2. And it looks like there's a question in the chat here. Anyone seeing an error, failed to find an object? Yes, we will get to this error in a moment. So sit tight. We will get back to this error in just a moment. So once you've got this template repository here, I'm just going to create this repository just so that you can see this working end to end here. It'll generate a new repository. It'll probably take a few seconds for you. And then we're going to go ahead and clone this repository. So now that you've cloned it, you can see it's generated from this Spinnaker Customized Patches. Go ahead and click on that code button, just like we did for Orca and Deck, and then clone it to your local machine. So we're going to move over to the terminal here, and we're going to talk a little bit about how this project is laid out. So I'll make this slightly larger here, and we'll just talk about what we see here at the root level of the directory. So I see a question from sudo. Does a repository have to be private or public is fine? Public is fine. There is a git ignore in this project that automatically excludes a couple of secrets files that we're going to be working with today. So don't worry about making it public if you want to show it off to your coworkers or do something else with it. So at the root of this project, this is basically all centered around customize. So as some of you self-reported, you're using Kubernetes at work. Hopefully you've heard of customize. Just at a very high level, for those of you that are less familiar, customize is a Kubernetes tool that allows you to create partial configurations for Kubernetes manifests that you apply to your cluster. And it kind of gives you a syntax for doing some very precise modifications to your configuration. So it's all centered around this customization file. So what you see on the screen here is API version in kind, as if you were modifying a manifest in the cluster itself. And then a couple of resources. And resources are kind of fully complete manifests that we're going to be applying to the cluster. And then this patches strategic merge key. This is going to show you, or this is going to kind of modify on top of what you're already creating. So we'll look at what this patch cube file is doing to modify this Spinnaker service. And the nice thing about this approach is that we can kind of give you recipes for modifying your Spinnaker cluster. So if you look, this customization file is actually already, it's just a symlink pointed to an already created recipe. So if you go ahead and look at the recipes directory, we provide, like a sample production EKS configuration, a quick start configuration, a minimum configuration. So we're pointing at the minimum configuration today, and that'll be fine just for what we want to work with today. So that we'll see this here. So let's start off with the first modification that we want to make. So let's go into our namespace key here, and go ahead and change that to the GitHub username that you use to register for the event. And you should have credentials for that. If you don't have credentials for that, let me paste the URL where you can grab your credentials real quick. So I'm going to go here and I'm going to go to Spinnaker. That's the wrong directory. Okay. And let's go ahead and create a new namespace. Perfect. So this is a good time to also talk about kind of the infrastructure that you're using today. So AWS graciously donated some compute time for us all to play around in this shared Kubernetes cluster. So I'm going to post a link in the chat now, and then hopefully these brackets don't get filtered out. Perfect. So if you go to that URL and then you type in your GitHub username that you use to register with the event, that should get you the configuration file that you'll need to interact with the EKS cluster. I also noticed in Slack earlier that some of you had set up Miniker. That's great. If you've got Miniker running and it's all good to go, then don't worry about these credentials, although you are free to use this cluster as well for your own purposes. So that username, going back to our configuration that's on the screen here, that's going to be what you put in your namespace here. Because if we go ahead and look at the cluster that we have here, if I go ahead and use my gardening credentials here, you'll have access to a single namespace. But if you want to, for example, get namespaces or do anything outside of the cluster, not really allowed. So feel free to do whatever you want within this namespace. This is yours for the duration of the event, and we'll tear it down at the end of Spinnaker Summit, at the middle of next month, I think, whatever date 4 weeks from now is. All right, so coming back to our configuration file here, your username goes in this namespace field. That's going to correspond to the configuration that you have. And then we're going to also remove a few things from the resources block here. So I'm going to not show that view, but go back to the default here and just kind of show you what we're going to be removing. So if we're going to go to recipes and we're using the minimum, perfect. We're going to remove this accounts spin-sa.yaml file. So basically what this file is providing is a minimal set of permissions that Spinnaker needs in order to operate within your Kubernetes cluster. Since we already created a service account for you, that's how you're authenticating with the cluster, we don't need to generate this file, and you'll still have permissions within your namespace to operate on Spinnaker. So all you're going to need is the Spinnaker service YAML here, infrastructure minio, and then you're going to be providing these two patches, which should be part of the default. So I'm going to take like a minute pause here just to let folks catch up, and then we'll pick things back up at 1:55. So Sudo has a question in the chat here. So the only change is to change the namespace for now. Yes, we're going to make a few more modifications before we deploy this to the cluster, but that's where we're taking a pause here. All right. So we're at this point, we've got our configuration on our local machine, we've changed the namespace. Now we're going to go into this patch cube file. So I'm going to go ahead and open it up here, but it's under accounts. I'm going to edit anyway. It's going to be under accounts, Kubernetes patch-cube.yaml. And so you're going to see a file like this, where we've got our API version and kind defined. And again, for those of you less familiar with Spinnaker, we basically have to define enough of this metadata here to specify the resource. So because our base Spinnaker service.yaml file defines these fields, we need to define at least these number of fields before we can start suggesting modifications to be merged into our main config. So we've defined our minimum set here, and then we're going to go in and we're going to have our spec. This should already be predefined for you. The only modifications that we're going to make is we're going to scroll down a bit, and we're going to go to this field that starts with namespaces, and we are going to specify a list, right? You could also do this with the brackets here. This is also valid if you wanted to do it this way. That might be a little less ambiguous for you if you come back to this later. But otherwise, define just the namespace that you are using in this workshop cluster in the namespaces field here. And the reason we need to do this is because if you don't define a namespace here, like a minimum set of namespaces that Spinnaker will control, this will actually fail to apply to the cluster. Because one of the things that the Spinnaker operator is doing, and one of the things that Halyard is also doing, is it's validating that Spinnaker itself has permissions to at least list namespaces, even if it never interacts with them. So by specifying a namespace here, we're essentially telling Spinnaker here, only look at this namespace. You don't need to list any other namespaces, and it'll be totally happy with that. So specify your namespaces here, and then if you scroll all the way to the bottom of the file, you're going to see this service settings block. So this is one of the things that operator allows you to do. It allows you to combine in one logical resource all of the settings that you need to start a service. So we're going to modify the service settings for Cloud Driver. We're going to specify this Kubernetes field, and then there's this service account name that Cloud Driver can use to interact with the Kubernetes cluster on your behalf. And what you're going to do is set the service account name to user. And the reason I say that is if we open up our garden file, our gardening days file, and I'm going to open up the user level file, you can see this is the configuration that you have to interact with the cluster. So I suppose now, because this token is on the stream, you could in theory mess around with my namespace. I'd appreciate it if you didn't. But what I want to show you here is that we're defining our user here to be, well, just the name user. I suppose it's not exactly defined in this file, which is fine. So what you'll want to do is you want to just change this to user, because that's the service account that we've created for you. You could also validate that actually by using your gardening file, and you could get service account. So let me do that again. So I have an alias in my local shell for KC. KC is equal to kubectl, so we could just as well call this kubectl, and the command is going to be the same. You use this kubectl flag to pass in the gardening days.yaml file, and then you can get service account. That's what we're talking about here. This user, that's the name that you're going to want to use in your configuration file. This is going to be created by namespace, so don't worry that the name is a little bit generic sounding. That service account is just just for your namespace. So go ahead and change the name there, and that should be it in terms of our patch for Kubernetes file. So we can go back to our customization file here, and so again, just to summarize, we've changed our namespace. We've modified this patchcube.yaml file, and that is another good stopping point. If you have questions, go ahead and put them in the chat, and let's start again at 2 o'clock on the dot. All right, so let's move on to the next stage. So in this customization file, you've also noticed that we've defined infrastructure and a persistence layer for Minio. And as I mentioned earlier, Minio is kind of an in-cluster S3 compatible object store. So we're going to be using that to kind of fake the presence of S3 in the cluster. So Spinnaker doesn't know any better. It's going to be interacting with Minio regardless. So we're not actually going to modify these files in particular. What we're going to do is we're actually going to talk about how secrets are managed in this repository. So what we use this repository for is really to kind of showcase all of the functionality that you can easily turn on and off in Spinnaker. So I wouldn't recommend that this is how you do your production secrets management, but for the purposes of today's workshop and for our development workflows, this works out just fine. So what I've done here is I've gone and edited the secrets directory, and I'm going to go ahead and edit this secrets.env file. If you've just cloned the repository, it's probably going to be secrets-example. So go ahead and rename that file to secrets.env, and then you're going to have all of these files here created. You're going to have all of these secrets here created, and these are all pre-populated just for the purposes of examples. So what you're going to want to do is you're going to want to have this Minio access key field here. You're going to want to change that to something that's greater than 8 characters. And the only reason I know it's greater than 8 characters is because I tried to create like a foo password earlier today, and Minio failed to deploy. So you want to make sure that that's at least 8 characters, and then go ahead and save that file. And then the way that we're going to deploy those secrets is we have this create secrets shell script, which is going to help us persist that information to the cluster. So you can run this secret script as often as you want, this create secret script, doesn't really matter. Typically what you're going to want to do is make sure that either the gardening days YAML is your main configuration file, or you set the kubeconfig to gardening days. So you're going to, in this case, this is fish syntax, but what you could do is you could actually export kubeconfig and set this equal to the gardening days YAML. So this is what you would put in if you were in a bash terminal. And so what this is going to do is all Kubernetes tooling will understand that if this shell variable is defined, it will use this first for its configuration file when talking to the cluster. And that way you don't have to specify the context all the time. Now, we have a question from Sudo. What needs to happen exactly here? So let's go ahead and repeat that very quickly. So we want to, in order to correctly configure Minio, we need to define a secret that is going to be shared between the Minio application that's deployed and the front 50 application that needs to talk to Minio. So in order to do that, you're going to go to the secrets directory. You're going to rename that secrets-example file from secrets-example to secrets. And then within that file, you'll change this key value pair from Minio access key, and you'll change this to whatever value. It doesn't really matter, as long as it's greater than 8 characters. So as long as it's relatively long, it doesn't really matter. And then we'll go ahead and take a pause there before we actually deploy the cluster. So hopefully, Sudo, that helps you along. I'm going to go to our Spinnaker Summit directory here. Perfect. Okay. So hopefully at this point you have everything configured, and we're going to actually deploy this now to the cluster. So you could execute a number of different commands to kind of get this running in the cluster, but what we're going to be using today is a helper script in the cluster. So in the repository. So we have this deploy.sh file, and then we're going to specify a shell environment variable before we execute the script. So the script is assuming that it is using the Armory operator. And since we are at Spinnaker Summit, we're going to be choosing the open source flavor. So as long as you define this environment variable, what this script is going to do is it's going to go through and modify every single file in the repository so that it has a spinnaker.io namespace. So I'm not sure who this was. I think it was Drew. So Drew was seeing this error earlier where the kind was set to spinnaker.armory.io v1 alpha 2, and Customize didn't really know how to modify that. So let me show you a concrete example of what that looks like. So if we go open this spinnaker.service YAML file, at the top of the file here, you see this API version. If you had just cloned this project, it would have shown something like spinnaker.armory.io. So the two operators, they've actually namespaced the custom resource definition that they've defined in the cluster. So by using that helper shell script, you can actually automatically change all of this to the open source version, so you don't have to manually touch every file. And this brings us to an important point. The one thing we're going to do before we actually deploy the cluster is we're going to modify the Spinnaker service file that's in the root of the project. This is very important. And then we're just going to scroll down to the version here. And you probably have something like 2.21.0. This isn't an open source version of Spinnaker, so you're going to go ahead and modify that and change that to 122.2, which is the latest version in the 122 line. So as we mentioned earlier, you might have noticed that 123 was released earlier today. Just to make sure that we don't have any surprises in the workshop today, we're going to stick with the latest 122 release, since there are occasionally API changes that we need to account for when we go from version to version in Spinnaker. So make sure you've set this version. And then if you want, what you can do before deploying is you can do a customized build. And customized build is not going to apply anything to the cluster. It's essentially a dry run. And it's actually going to show you all of the configuration that we put together in order to create this cluster. So you'll see a service created for Minio, a PVC for Minio so that it can actually store stuff with just like a very small storage set, a stateful set to make sure that we're running where we need to be. And then you'll notice here, let's see, we should see an example of some secrets being created. Perfect. So the reason that we've modified that secrets.env file is because we've actually supplied an encrypted secret here. So you can feel free to commit this to your repository, and you'll be rest assured that the secrets.env file will not be committed. And whenever you actually apply this, the operator is responsible for decrypting this access key and injecting it into the container before it's created. So if you're still seeing an error, Drew, that's usually a customized error that I'm seeing. Go ahead and try running this deploy script here. So again, spin_flavor equal to open source, and then just deploy. We'll go ahead and run this, and you'll see a few log messages. And it's complaining because I likely have not set my kube config like a good facilitator. Interesting. So let's go ahead and set this to the correct one here. And I think I see the issue here. Yes. So you do not have permissions to actually run this script. Okay. So let's adjust. Let's adjust in the moment. Let's go to our customization file here, and let's manually modify these files here. So in Spinnaker service.yaml, let's go ahead and open that file up. Go ahead to API version. You will likely see spinnaker.armory.io, right? So if you see this at the top of your file, go ahead and remove that so that you have spinnaker.io v1 alpha 2. And I will go ahead and paste that in the chat here just to make sure that you have the right API version at the top of all your files. So if we go back to customization here, let's go, that's okay. Okay, let's go to our customization file, and let's move on to the next one. So we have this persistence patch Minio. So persistence patch Minio, also going to have a different API version. So again, if you see that armory there, just go ahead and remove it. And let's go back to customization. And the last file that we should have to worry about is the patch cube file. So go into the patch cube file, edit that file anyway, and then make sure that that API version is correct. And so once you've made that change, you should be able to run customized build, and you should be able to see a completed manifest. So since that's a bit of an unintended detour that we've taken here, why don't we take a minute? Yeah, so at 2:10, let's return, and let's go ahead and deploy this into the cluster using a few manual commands. Yes, sudo. Go ahead and change all 4 files so that the API version matches the open source CRD version that we'll use today. All right, so let's go ahead and resume our journey here. So since we're not going to be using this deploy script, we're going to run a few of these commands manually. Really what that deploy script is doing under the hood is it's adding a few nice log messages to kind of warn you when certain conditions are not met, but that's all right. We will go ahead and use these utility scripts directly. So the first script that we're going to run is going to be the create secret script. So we were modifying that secrets.env file. We're going to go ahead and create everything now. So what we're going to want to do is we're going to want to define this namespace variable here at the beginning. So I'm going to set namespace to the namespace that I'm currently deploying into, and then I am just going to invoke directly that create secret script. If you didn't export the kubeconfig variable, then you will want to set that as well so that the script functions properly. So you will want to provide that kubeconfig value there. And then when I go ahead and execute this, what you should see is if you did this successfully, you should see the script talking about all the passwords that it's going to include. And then it's going to tell you that it created this secret and give you a summary of everything that it created. So what you can do to validate that your Minio access key was created successfully, 3 bytes is typically the empty version, the dummy version of the secret. So if you see a value greater than 3, then that likely means that your secret was created successfully. So for me, based on the length of the secret that I created, it came out to about 29 bytes. So yours might look a little bit different here. So once you have run this script successfully, you should be able to also validate that manually by going into the cluster. So you can get secrets. And you should see this spin secret created here. For me, it was created about 53 seconds ago, and it's got quite a bit of stuff in there. So this is what's actually going to be used by those pre-created operator configs for you to get everything working. So once we've done that, we're going to go ahead and we're going to apply this customization ourselves. So I've been talking about using customized build here, but if you don't have the customize tool installed, we're going to show you a different way of getting this installed in the cluster. So kubectl actually creates, actually bundles a version of customize whenever you install the tool. So the way that you would invoke this tool is kubectl apply. You're typically used to passing in F for like a file. So, if we just tried to apply Spinnaker service.yaml, we would get an error from the operator because we don't have a complete manifest here. So what we're going to do instead is we're going to pass the -k option, and we're going to provide dot, and that's going to be for the current directory. And then somewhere in your command, don't forget to set kubeconfig equal to your gardening days YAML file. And you should be able to run this directly. And so you can see that, at least for me, I haven't modified anything in my cluster. So these 4 resources have remained unchanged. But for you, you will likely see created or configured if you were trying to run this command already. And then you should be able to run either a kubectl command directly, where you just get pods within the namespace, or if you have this watch tool installed, you can go ahead and pass it into watch, and then we'll see all of this stuff is running in here. So this is using a different YAML. So we can go ahead and run this and make sure that this is part of my namespace. And there we go. There is our cluster here with Minio running and all of our services configured here. And I see a couple of notes from sudo here. That first kubeconfig, yeah, those export commands are correct. Yes, so thank you for doing that. So now we're going to wait maybe like 2 minutes here. Make sure you post any questions in the chat, and then once you've got your Spinnaker cluster installed and up and running and successfully able to mess around with stuff, we'll show you how to interact with the cluster using kubectl to port forward to your local machine, and then we'll actually start getting into some code. So sudo asks, what's after kubectl apply k? In terms of the command or just what happens? So your command should look something like this. I'll go ahead and clear the screen here. So you pass in your gardening days YAML. You don't have to provide that if you've exported it like you have in the chat there. And really what you should see are these 4 values here. And if you repeatedly apply these changes, you'll see this unchanged value. But if you modify anything, oh, I see. What's the command? So if you have watch installed, if you're on a Mac, you can brew install watch. And watch is kind of a nifty tool that just automatically refreshes like every 2 seconds the command that you pass in. And you're getting an error. So why don't you explain to me a little bit about the error that you're seeing? All right, Sudo. So I'm seeing that there are some permissions errors that you're seeing. Chances are that is because you're trying to create a service account and a cluster role that you might not have access to. So in this resources block, there was probably a reference to accounts, Kubernetes, spin.sa.yaml. You want to make sure that this is either commented out or completely removed. Because you won't have access to create cluster roles in this cluster, unfortunately. So just make sure that that's not provided here, and you should not be creating that resource anymore. If it's still complaining, what you could do is you could run delete-k dot, and that will actually just remove everything. And since we haven't really done any meaningful work, it's probably going to be the quickest way to kind of reset your environment, and then you can come back and do an apply k in the current directory. So go ahead and give that a shot and let us know. And we'll give it maybe 1 more minute before we move on. All right, sounds like we have resolved the issues. That's great. All right, so let's move on to the next step. So at this point, we should see a successfully running cluster. Hopefully this has been enough time for all of these services to get started. One potential thing that you might see is that the status might show as pending for some of your pods. That is somewhat expected, right? So the more people we have operating on this cluster, the more resources we're going to be requesting. For those of you familiar with EKS, we do have worker node auto-scaling set up in the cluster here. So it will end up scaling up, but it might just take a few minutes before nodes are added to the cluster. So just go ahead and wait a little bit, and you should see everything up and running eventually. So I'm going to go ahead and get out of here. We have a question here. The command after customize. The command after customize, if you don't have watch installed, is just going to be kubectl with your kubeconfig and get pods, and that'll show you all of the resources that are running in your cluster. And Drew, it looks like you replaced every instance, but you're still seeing an unknown source. That is unfortunate. Is it the same error as before that you had pasted earlier? It is the same error. All right. Try this part of the setup. It would be helpful if you can post the error message. Oh, kubectl pods watch works. That's good to hear, sudo. And it's up. That's great to hear. So Drew, if you could post the exact error that you're seeing from customize, we can try and debug this in the spaces that we have in the next couple of sections, just to make sure that we keep moving along. We're unfortunately going to have to move forward, but I'm confident we can get you on the right track in between these breaks. So let's move on to the next step right here, and we'll take a break after we can see ourselves interacting with the Spinnaker cluster. So the next thing that we're going to want to do, now that you have a successful cluster stood up, is you're going to want to port forward a few services to your local machine. So this is a thing that we do pretty commonly to interact with the cluster. Typically what we will do is we will create a few different splits. So I'm actually going to close my lower left split here, since that was previously running deck. And then I'm going to exit out of this command. So I'll make these a little bit larger so that we can actually see the command that we're running. I'm going to make this kubectl again. So kubectl has the ability to port forward things to your local machine. This is very useful, especially if you are wanting to work on Spinnaker, because it's unlikely that you're going to be running all 10 services on your local machine. So we're going to use this kubectl command here, again, passing in our config file. We're going to use the port forward verb and then the service spingate noun. If you're less familiar with kubectl, this is kind of a neat trick. You might know that you can pass in like an exact pod name in order to port forward something. But kubectl is actually smart enough to know that if you specify service, and SVC is the short name for service, so this is actually an equivalent command as well. You can do service/spingate and then the port that you want to port forward to your local machine. And if that's successful, you should see this message here where it's forwarding 8084 to your local machine. So that's perfect. And then don't worry if you didn't see that command, we're going to show it again. So I'm going to go ahead and port forward spin deck this time. So again, kubectl, our config file, the port forward verb, we're going to specify the service for spin deck, and then we're going to choose 9000 this time. And when you execute that, you should be able to see that you have localhost 9000 working. And now, if I go to a new tab where I didn't have Spinnaker running before, and I just go ahead and run localhost 9000, you should see this Spinnaker loading page. And after a moment or so, you should be dropped into the Spinnaker UI. So at this point, go ahead and play around with the Spinnaker UI. If you want to get ahead in the workshop, go ahead and go to this Applications tab here. Go ahead and click on Create Application. Choose whatever name you want, something fun maybe. And then the owner email can be anything. It doesn't have to be routable. So what I've been doing is I do demo@example.com to make sure that Spinnaker will never accidentally send a message to an address here. And then you can go ahead and click on Create. And that's going to drop you into the new, as of 122, UI for deck. And then on the left-hand side here, you're going to want to click on Pipelines and configure a new pipeline. Give it a fun name if you want. So let's go ahead and click Create here. And then we should see after a moment that we are dropped into the pipeline stage here. You can go ahead and add, if you want a simple pipeline here, go ahead and in the center of the UI, click on Add Stage. That'll take you to a new stage here, and then type, go ahead and type in wait here, and that'll give you a wait stage, and then you can have it wait for 30 seconds, save changes. And at this point, we have a minimal pipeline. And what you should be able to do is go back out here, click on the right-hand side of the UI, start manual execution, go ahead and run, and you should see this pipeline run and just run for 30 seconds. It's not super exciting. But go ahead and continue to click around, explore the UI for a little bit, try messing with a few stages. If you're already familiar, go ahead and take a quick break, grab some water, and let's return in about 3 to 4 minutes. And Drew, if you could, please put your customized errors in a paste bin or something, or maybe message me on Slack and we can try and debug your customized issue in a little bit more detail. All right. So hopefully at this point, you've been able to get to the Spinnaker UI and you've been able to mess around with a few things. You've been able to get to this pipeline here, and you've got your 30-second wait pipeline successfully executing. That's great. So let's go ahead and move on and talk about the next tool that we're going to set up. So everything to this point has really been a one-time setup, right? For your development environment, this is a cost that you pay once when you're starting, and then every time you develop the service, all the steps we're going to talk about now, that's what you're going to do every time. All right. So when we typically want to modify a service, there's two different ways that we go about it. You can either modify the service, you can build a Docker container, you can publish it, and then you can point operator to that new image, which is a little tedious, but it's certainly the simplest way to go in terms of development complexity. Or you can choose this tool that we're going to use called Telepresence. And we're just going to show this, this homepage here. And what Telepresence does is it creates a bidirectional proxy for you to interact with services and then also have the services within a cluster interact with you. So this is actually a really neat piece of technology, because what it allows you to do is it allows you to run a service locally on your machine and pretend as if it was running inside of the cluster. So when we go ahead and look at this diagram here, we can actually see all of the different services that we have to interact with. And you can see all of the arrows pointing into Orca, right? Orca needs to interact with a number of different services. So typically, if you needed to make a modification to Orca and see that reflected in your Spinnaker cluster, you would again have to build an image, or you would have to modify some configuration on the pod itself and restart the service, which is typically not what you want to be doing. So let's go ahead and use this Telepresence tool. Hopefully you have installed it already. If not, I believe we have instructions here in the contributors workshop for installing Telepresence. Here in this installation software, you can see Telepresence. So if you have Homebrew installed on a Mac, you can go ahead and brewcask install OSX Fuse, and then brew install DataWire Blackbird Telepresence. One thing to note about Telepresence and OSX Fuse is that if you have not used OSX Fuse before, you will probably see some errors on newer versions of Mac OS. This is because OSX Fuse needs elevated privileges to create what is essentially a virtual file system on your machine. So what Telepresence is going to do is it's actually going to mirror the entire file system from the pod onto your local file system using this OSX Fuse tool. It's very neat, and unfortunately we just don't have a ton of time to talk about it in detail today. But we're going to use Telepresence here to actually swap the development of the Orca pod that we have in the cluster with what we have in our local machine. So what you're going to want to do, I will go ahead and make this a little bit larger. Sudo, it's great to see. You can see the application and you have everything installed. That's excellent. So we're going to specify kubeconfig here. If you've exported it, great, no need to worry about it. We're going to call Telepresence. In this case, we have to specify namespace. Since Telepresence is not developed by the core Kubernetes community, it doesn't respect some of the same options. For example, it won't respect the namespace field, as far as I'm aware. There might be a newer version that does, but as far as I know, we have to specify the namespace flag here, even if it is specified in your config. We're going to want to swap deployment, and then we're going to specify the deployment that we want to swap. So in this case, we're going to do spin-orca, and I know that off the top of my head, but not because I'm very smart. It's just because I've been typing these commands in quite frequently. If you want to understand what deployments you can swap, you can run this kubectl command and get deployments, and it's going to show you all of the different deployments that you can swap in your cluster. So today, because we're going to be working with Orca, we're going to want to go ahead and swap the Orca pod. So going back to our command here, we're going to swap deployment for spin-orca. And then we're going to pass in this --m file. And let's see, if I make it smaller, I can get it on one line. Perfect. So .m file, and then we're going to call it .m telepresence. And what this is going to do is it's actually going to mirror all of the environment variables that are defined inside of the pod into this .m telepresence file. So I'm going to go ahead and make it a little bit larger, and I'm going to go ahead and run. It's going to ask you for your password. You might see a few error messages. That's all right. As long as they're just warnings, that's fine. One thing I will call out is that Telepresence doesn't play very well with VPN proxy. So if you are using your work laptop and you use a VPN to connect to your company's resources, you might run into issues here. It's not always a sure way. It's not always a sure thing, but sometimes it happens. What you're going to want to do in that case, and I will paste this link in the chat here right now, but what you're going to want to do is you're going to want to try one of these other proxying methods. So by default, I think it's going to use maybe this VPN TCP. I can't remember offhand which one it uses by default, but basically play around with the connection methods and hopefully one of those works so that you can actually swap your deployment successfully. So that is a thing that you will potentially run into if you're using a VPN. Again, check the Telepresence link in there. So now if we go back to our terminal here, we should see, if we've done this successfully, a bash terminal. And you'll know that you have successfully done this because it will say gardening days cluster, and you'll have a little bash shell here. So this is kind of an environment that already has a number of telepresence, for example, root. This will tell you where the root file system is from the pod that you just swapped. It also has, I think, everything proxied from the container. So if we did like spin cloud driver, for example. So again, if you're not familiar with Kubernetes, a lot of what these environment variables are, this is the kind of in-cluster service discovery mechanism. If you don't want to use DNS, it's going to populate a whole bunch of shell variables in the pods that it creates. So it'll pre-populate a whole bunch of that stuff. And so what we're going to do when we've got telepresence here is we're going to want to copy, and I'm going to just copy it here. So we're going to copy recursively everything from the telepresence root. Again, so we're going to go into the file system of the Orca pod, and then we're going to do /opt/spinnaker/config, and we're going to copy all of that stuff into a .spinnaker directory in our home directory. And so chances are you might see an error like this. That's totally fine. Just go ahead and blast this stuff away. Typically what's in this directory is configuration that is relevant for the services that are starting up. So the reason we want to copy these files over is because this is going to have all of the information required to talk to cluster services available to Orca when we start it locally. So we can go ahead and take a peek at what's in that Spinnaker directory. There's the Orca local files, the Spinnaker local files, and if we look at the Spinnaker local file, for example, so let's go ahead and open up Spinnaker local. No, that's empty. Let's look at just the Spinnaker file. Here we go. So when you open up the Spinnaker file, you'll notice that this actually has pre-populated all of the DNS entries for the services in cluster, right? This is not pointing at something locally. And so this is the other neat thing about telepresence, or kind of scary thing, depending on how much tinfoil you want to put on your head. But telepresence is actually going to hijack your DNS so that it can actually resolve stuff that's in cluster. So for example, when I ping spin Orca, right, this is actually going to make a query to a resource that's inside of my cluster. And it's not going to resolve. So again, that might be why the VPN approach is a little more fraught with peril. So this has been a lot of information that we have covered so far. So let's go ahead and take maybe a 2-minute break here. Go ahead and again, post your questions in the Spinnaker Summit chat. And I'm going to go ahead, Drew, and check in with you again and make sure that you have what you need. Yeah, sudo. So that was one of the error messages that I was telling you might run into. So if you go into that security tab, yeah, so you're probably going to have to restart the telepresence prompt, because if OSX views didn't start successfully, then you're not going to see anything when you might have this telepresence root directory showing up, but there's probably not going to be anything in there. So go ahead and go to that security and privacy tab and make sure that OSX views has the permissions it needs to run, and then restart telepresence. And then what you should see, if you go ahead and just kind of list what's in there, you should see the file system for the container that was running. So if you run this and you don't see anything in there, you're going to have to make sure that you accept the permissions in that security and privacy tab on macOS. So I'm actually going to take a moment to explain an error that Drew was seeing, which is typical if you're either starting out or getting used to customize and kind of the way that it resolves. Drew, it should not have the namespace there. The namespace will be provided by Customize. So I'm going to go ahead and go to Spinnaker Summit here, and I'm going to look at the customization. So what's actually happening here when we define namespace is Customize is going to apply namespace to all of the different resources that you create, which is why when you look at the like patch kubeconfig file, for example, and again, we're going to edit only, which is why when we look at the metadata here, we don't have to provide the namespace. So Customize is going to inject the namespace here, so we don't have to provide it. Don't need it. But the way that it's going to resolve objects, and now I'm going to look at Spinnaker Service. So because Spinnaker Service is a resource, right, all of the information here in this metadata block is going to be used to uniquely identify this object. So if, for example, we were here in this kubeconfig patch file and we changed this to my username, for example, all of a sudden when we go to customize, if I just go ahead and get out of here and I try and do a customized build, you're probably going to see an error like this, right? And so this is actually pretty common. Unfortunately, the error message isn't super great. So I'm going to explain kind of how to read this. So you're going to have the kind here. So this is the the version of the object that we're creating. And then this is the name of the resource. And it's saying that there is no matching resource for this thing. There was, failed to find a unique target, right? And so basically all that that's saying is that you need to go audit all of the resources that you've defined here. So these resources are going to declare kind of your unique targets. And then these patches, they have to associate with a unique target that you have. So now if we go back to patch cube and we change this back to Spinnaker and we go ahead and run customize build, all of a sudden now we've got our configuration building, because all of this stuff is kind of associated together now. So Drew, hopefully that unblocks you and you can play a little bit of catch up here just to make sure we continue to move along. Let's check into the chat. So sudo, oh, I'm so sorry, your machine is managed by Jamf. Hopefully you can get an admin to help unblock you there. But we'll go ahead and move on to the next stage here. So what we've done to this point is we've started Telepresence here. And Telepresence is a tool that we will always start up when we want to modify a service that needs that two-way or bidirectional communication. So now we're going to run Orca in IntelliJ. So you can use this shell. This is a fully compliant bash shell. It just has some, environment variables pre-populated for you. Or you could use a totally new shell, and you're just going to want to make sure that you're in that Orca directory, right? So if you did not run the telepresence command inside of the Orca directory, then you're going to want to make sure you know where that .env telepresence file is, because we're going to reference that when we set up IntelliJ. So we're going to fire up IntelliJ. If you installed it earlier in the day, what you can do is you can do an idea dot, and that's going to open up the project. So we can see here it's already opened up, which is great. And typically what you will see is import, like you're going to want to import a Gradle project, choose all the default settings, and then it should drop you into a project like this. So looks like the service failed. So that's perfect. We will go ahead and reconnect in a moment. So you should get dropped in here. I have pretty much mostly default settings, although the editor plugin that I'm using here enables VI key bindings. So pretty much everything should look the same to you if you're using the community edition. A few things might be tweaked if you're using the premium edition. Again, I'm not using the paid for version of IntelliJ here. I'm just using the community edition. So you might need to modify instructions based on the version that you're using. So what we're going to want to do is you're probably going to be sitting here for a little bit. Orca in the lower right here is probably going to have a whole bunch of Gradle tasks running to download dependencies, do all that sort of stuff. So while that's running, if you can, go up to the upper right of your IntelliJ window here and go ahead and click on Edit Configurations here. And I apologize, I can't make the UI any larger, but I think we might be able to have some help from our producers here to kind of enhance this view a little bit. And what you're going to want to do is you're going to want to click on the plus here in the UI, and then you're going to want to create a new Gradle configuration. And then you'll go ahead and give it a name. I call it run, I suppose. And then here in the Gradle project section, you're going to want to choose the task that we're going to use to run the project. Most of the JVM services in Spinnaker are going to define a like service name -web target. And so what you want to do is you want to look for that target somewhere in this list. Let's see if we type it in. Look at that. That's very nice. So we can go ahead and click Orca Web. And so Orca Web is just kind of like the main entry point for starting the API server. So we'll go ahead and choose that as our project to run. And then let's see, what other configuration objects do we want? We want to choose the run task. So you've got Orca Web set up here. You've got tasks set up here. And then if you were able to set up the IntelliJ IDE before we started this workshop, you should also see a tab here called env file. Now, if you didn't have that set up before, let's talk about that real quick. So if you hit Command comma on your keyboard, or if you're on Windows, I believe it's like Control-Shift comma or something like that, or you can just go up to the top left here and click on Preferences. All those roads will lead to the plugin page of Roam. You can go ahead to plugins here in this left-hand dropdown, and you can go ahead and click, type in mfile, and that should populate the plugin here. It is a free plugin. It's available for community and paid editions. You can go ahead and install it, and then you will probably have to restart your IDE. So once you have that plugin, you'll be able to come back to this configuration here, and you'll be able to click on mfile. An mfile, you're probably going to have to enable it. So go ahead and click on enable. And then you're going to create an entry here for the .env telepresence file that you created. So the way that you're going to do that is in this table view, in the lower left of the table view, there's going to be a button here for plus that you're going to be able to add an m file. It's going to give you a view. So if you're on Mac OS, this is what it's going to look like. A tip, if you're not in the right directory, you can hit Command-Shift-G here, and it'll bring you up to this go-to folder. So I'm going to go to where I have Orca checked out on my local file system, and then you'll see all of the files here. And then if you called it .env telepresence, go ahead and choose any file here. You're probably not going to see it in this view. So go ahead and just choose any file. And then once you're in this view, you can go ahead and double-click inside, and then you can call it .env telepresence. And that's how you get the telepresence set up here. And so This IntelliJ setup is a one-time deal as well. You won't have to set this up all the time. What you will see here, if the .env telepresence file is not found, this is actually going to show up red in the UI. That means that IntelliJ was not able to find this file. So again, if we go back to the terminal and we go to this telepresence command that we created, and you ran it outside of the root of the project for Orca, then you're going to want to make sure you grab that file and paste it into this location here. And at that point, IntelliJ should know what's what. So what we should be able to do at this point is we should be able to click on the run task for Orca, and we should see it successfully run. Some of the things that you might see at this point, it's okay if you see some of these warning messages here, but one common thing that people run into is they start seeing exceptions when they run this task, and it's complaining about being unable to find a bean for a fiat permissions evaluator. That is unfortunately an expected error, but it's very easy to fix. So all you need to do is you need to remember to run your copy command, right? So copy the Spinnaker config from your container and mirror it to your local Spinnaker directory. And if you've been successful, you should start to see this started main message here at the bottom. And that will mean that Orca has been successfully run. And if you want to validate that that is still working, you can go ahead and go back to the Spinnaker UI. You can go ahead and start a manual execution, although it looks like I lost connection to my pods. So I'm going to go ahead and restart those. And again, I'm not a magician, but I look in the top left of the UI here, and if you see this little application dialog, you can hover over it. And so what I noticed earlier is that it was kind of grayed out, and it didn't show me that things were updating here. And there's also this error message that shows up talking about executions. And when you hover over it, it'll tell you when it was last refreshed. So that'll kind of give you an indication in the UI whether you've got everything hooked up successfully as far as your port forwards go. So now to test that gate is still working, we should be able to still see this application running. This pipeline running. And we can see, because this is still running, we can go to task status and we can see wait still running. So that tells me that Orca is still running successfully based on our swapped pod. And we can go to IntelliJ here and we can see a whole bunch of request responses. This exception is likely, complaining about a pipeline that doesn't seem to be found. That's okay. But we are receiving traffic from other services within the cluster. So again, this is a lot of stuff to take on. So let's go ahead and take 3 minutes this time. And we will resume at 2:55 Pacific time. And go ahead and put your questions in the chat. And we'll see where we're at in a few minutes here. All right, so let's go ahead and resume our journey here. So just taking a quick look at the time, we have about 35 minutes left. So I imagine what we're going to be able to do is discuss in detail some of the changes that we'll need to make to Orca, but we're probably going to have to gloss over some of the details for modifying the deck UI. So what I am going to do ahead of time is I'm going to provide access to the code that we will use for deck, and then you will be able to use that when we get to the deck portion. So let me just grab that real quick. So I'm going to go ahead and grab this URL, and I will paste it into our chat here. Perfect. Okay, so go ahead and check out that gist in a moment, or keep it in your back pocket, load it up, and we'll review in a moment. So let's go ahead and dig into deck here. So let's talk about how deck is organized. So if you refer back to the beginning of the workshop, I'm going to go ahead and show the left-hand side here in a little bit more detail. And again, I apologize, I can't make the UI a little bit larger here. So hopefully our producers can help us out here. But let's talk about how the project is organized. So Orca, as we mentioned earlier, is the orchestration layer for the entire cluster. This is going to provide tasks and stages for Spinnaker to execute within a pipeline. It also provides a number of other tasks for non-pipeline related things that we're not going to delve into too much today. But basically, Orca is broken up along the lines of what services it interacts with or what tasks it provides. So for example, if you want to interact with Kyenta in a pipeline, there will be Orca tasks and stages that are defined in this package here, Orca Kyenta, that you will refer to implicitly in your pipelines and deck. So you can find all of this stuff here. You know, for example, if you want to do something related to peering or do something related to queuing, like all of this stuff is broken out into packages. And then, you know, if you're curious about how like the Kubernetes stuff works, for example, you can go ahead and open up the Orca Cloud Driver package, go down, drill down. Of course, this is Java land, so we're going to be going for a little bit. And you can see in pipeline, let's say artifacts, for example. If you want to run the find artifact from execution stage in a Kubernetes pipeline, this is the way that you would do it. And so let's just use this as an example to talk about how we would, or kind of the anatomy of a stage. So a stage is essentially defined using the stage definition builder class. And really the only thing you have to provide as a developer looking to add new stages is to define this task graph method. So a stage can be composed of many different tasks, and they don't all have to complete at the same time. They don't all have to execute in a linear path. So that's why we call it a task graph, because you can kind of build up a graph of operations that you want to take within Spinnaker, or even without Spinnaker, and await their completion. And Orca kind of provides this mechanism for monitoring the progress of tasks. So, you know, if you want to go check, you know, I don't know, a stock ticker or something, you know, if you want to stop a deployment if the stock ticker is going down more than 10%, then, you know, that's something that you can do as a stage, right? And you can prevent Spinnaker from deploying a bad version of your service if you notice the stock ticker going down. I'd be curious if somebody builds that to let us know how that works and if that's a reliable indicator or not. But anyway, so you have this task graph method. So you're given a stage you're given the stage, right? And the stage contains contextual information about what's happening in the pipeline at any given time. And then you have the builder here, which is going to help you define, it's going to help you define where you define tasks and kind of where you pass information along. So this is a very simple stage, right? It's only got one task. So you use your builder and you pass in a task name and then you pass in the class. If you're less familiar with Java, there are a few things in here that we need to talk about. There is a framework called Spring. In particular, Spinnaker JVM services are using Spring Boot. And one of the key features of Spring is it provides this very sophisticated dependency injection system. So we don't have to you know, meticulously build a graph of all of the classes that we need for things. So one of the ways that this dependency injection works is with this very important, almost mythical annotation that you will add to your classes. So this app component annotation is going to be very useful for you to help your class be discovered elsewhere in the project. So for example, if you're wondering, how does this find artifact from execution task get instantiated? How does it get added to the task graph? How does it do all that sort of stuff? Let's go ahead and open up the task itself. So to answer the first question of how that component, how this class gets discovered here for this builder, well, again, it comes back to this component annotation, which is going to register this class with the framework and allow it to be instantiated. And what you're going to need to provide inside of these tasks is an execute method. So every task is going to have one execute method, and this is where all of your business logic is going to live. So again, if you want to go check out the Yahoo Finance API and look at the stock ticker for your company, this execute method is going to be where you do it. And this, you could do pretty much anything you want in here, as long as you can instantiate it as part of your class and bring it in. So in this case, we're looking at the literal source code for the find artifact from execution task stage in Kubernetes. So we're going to do that at a simpler level for the stage that we're going to be adding. So if I go back to my original example here, and I look at our manual start stage, basically we're going to be adding a stage called my stage. The only thing it's going to provide is a simple status message, and we should be able to see the task status duration here show up. So this is essentially what we're going to be doing. So in order to do that, we're going to create a new class, and I'm going to go ahead and show you where in the tree we're going to create that. So just for the sake of today's workshop, we're going to go ahead and modify the Orca core package, and you're going to want to drill all the way down source main Java com Netflix Spinnaker Orca pipeline, and then inside of that pipeline directory you will create two classes, one class, my special stage. You can in theory call this whatever you want, but we're going to go under the assumption that we're registering the class as my special stage. And then inside of the tasks directory, if I go ahead and drill down here, we're going to have a task. So in this pipeline directory, there will be a subdirectory called tasks, and we will create another class in here called my special stage start task. So if you're less familiar with IntelliJ, the way that you would do that, for example, if you wanted to create this start task, you would go drill down to the subdirectory, go to new, and then go to Java class, and then call it my special stage. And in this case, we'll give it a unique name. You don't have to provide the Java ending. IntelliJ will do that for you, and you just provide class here, and then you are given the bare bones version of a new class here, including all of the copyright information that you need for the project. So the next thing that you're going to want to do here, so if we're referring to our my special stage class here, is you're going to want to implement that stage definition builder. So again, just to walk through with it with everybody, we're going to do implements stage builder, stage definition builder. You can go ahead and tab complete, and that will automatically import the file for you. And then once you're inside, you will want to override that task graph method. So you can, I think it's Alt Enter, no. Well, there's a way for you to do it, but we can just do it manually. So you're going to override this signature here. There is a shortcut for you to do this, but I'm not going to spend time figuring it out live here, just for the sake of keeping things moving. So you can go ahead and override this task graph method. And then inside of this builder, you will go ahead and add with task. And then you will provide the stage name, so my special stage start. And then what you're going to do is you're going to pass in the class. So I'm going to pass in my special stage start task since I've already created it. And then go ahead and that's essentially what we've done here for this task, right? So we've called our builder, we've given it a name, we've passed in the stage start task. So if you haven't created the task class yet, that's okay. I didn't explicitly tell you to. So let's go ahead and look at the anatomy of this task here. So again, we've defined our special start task. We've defined our execute method, and we're not going to do anything special here. We're just going to immediately return a result. And this task result helper or Fluent API is going to give you a number of different options to configure the response that you send back to any service that's consuming messages from Orca. So in this case, DAC is going to be querying Orca for the result of this task. So we're going to provide this builder method, and we're going to make sure that it succeeds. Then we're going to pass outputs. And this outputs builder here is going to allow you to pass key value pairs back to DEC. So you might be able to see stage start status is set to hello. And if we go back to our UI, we can see our hello message here. So we'll see towards the end of this workshop in about 20 minutes here what it looks like for us to pull information out of the Orca task outputs, and then go ahead and call our builder here, our build method, and that will return a task result to the parent stage. Now, again, if you're like me and you frequently forget things, you will have probably forgotten to add the component annotation to this class. So when we get to the DEC portion and you start seeing Orca errors and you start seeing class instantiation errors and you're wondering why, you followed everything Fernando said, it's probably because you forgot this at component annotation, and Spring doesn't actually know how to resolve the class that you're passing in to the stage builder here. So this was a veritable deluge of information. So let's take a pause here for about a minute and make sure that we have any questions answered, and we'll move on to the next stage of actually restarting our service here and seeing it run. All right, let's go ahead and continue on checking into the chat too. I'm very glad that you're enjoying the workshop and you're learning a lot. Hopefully that's the same for the rest of you as well. So let's go ahead and restart our service here. So we didn't actually make any code changes. So this service doesn't need to be restarted, but maybe it would be instructive if we showed what the error would look like if we didn't have this component annotation. So I'm going to go ahead and remove the annotation on the stage itself, and I'm going to restart the service. So let's go ahead and restart the service here, and then everything should be set up on the DEC side. I'm going to cheat a little bit here, and I'm going to start my local DEC service with these changes already made, and I'll just kind of show you what the error looks like on the UI side. So you're not necessarily going to see an error when the service is starting up, but it's possible we might. If anything, we'll get a nasty gram from the Gradle compiler that we have an unused import, but fairly certain we will start up correctly here. Okay, just seeing a few warnings, that's all right. And this compilation process is going to take more or less time depending on how many resources you have available on your computer to throw at this thing. This is, again, another reason why we don't run all of these services locally in a typical scenario, because they are fairly resource intensive. All right, so it looks like we managed to start the service successfully, which is more or less what I figured would happen. So that's good to know. So our service has started. It's responding to requests. So let's go ahead and refresh this page again with our local version of Yarn that of DEC that already has these changes. If I go ahead and configure my stage, we see all this information here. That looks good. If I go ahead and run this, I expect this pipeline to fail, and it's going to give you no message, right? It's not going to give you any context as to why this failed. So now if we go back here, we should be able to see this lovely error message. So what this is telling you is no stage definition implementation for my special. So basically Deck sent a request, hey, I want you to start this stage and within this pipeline, and Orca said, okay, I will listen to you. I will look for this class, and it didn't find the class. All right. So now when we go ahead and add this component annotation, this is going to properly register the class. We can go ahead and rerun Orca here. It'll take roughly the same amount of time to get started. And when we go ahead and rerun this pipeline, we'll go ahead and see it working again. So while this is compiling and while this is getting ready to run, I'm going to shift focus. So we're going to leave the JVM world. We're going to stop talking about Java for a moment, and we're going to start talking about Deck. So Deck is this lovely UI that we've been using for the duration of this workshop. It is architected a little bit differently. Basically, as I mentioned at the very, very beginning, almost feels like a year ago now at this point, right? This project is architected in a mix of React and Angular 1. And I use 1 very intentionally. It's not the latest version of Angular. So Spinnaker is a fairly mature project. Again, it's been in development for quite some time. So Angular 1 was kind of the du jour framework. And as time has gone on, the community has decided that React is the better framework to go forward with. So rather than doing a complete rewrite of Deck, everything's been moving in stages, right? So as people work on these projects, or as people add new functionality to Deck, they're doing so in React. And a few folks, bless their souls, they are migrating all of this Angular code over to React as they have the time and bandwidth. So it's possible that depending on the part of the code base that you're working on, and depending on the kind of feature that you're trying to work with or modify or add, you might run into some of this Angular code. For the purposes of today, we are going to be dealing almost exclusively with React. So we're not going to be touching Angular much. And just to be totally upfront, I'm not a front-end expert by any means. I'm certainly a platform engineer by trade. So if we run into issues with Deck, I will certainly do my best to answer them. Hopefully we don't run into anything too weird. So what I'm going to show you, since we don't have a ton of time left in our workshop, I want to go ahead and talk about kind of how you would add a new stage at a high level. And if you refer back to the Spinnaker Summit chat, that gist is still the last message in the channel. Go ahead and pull that up, and you will see a gist that I have authored for this workshop. At the beginning of every file, you are going to see a path where you should be putting the contents of those files. Make sure those names are correct, unless you modified them in Orca when you were making these changes locally. So let's go ahead and talk at a high level. Let's say I've already got a stage, right? How do I add it to the registry for Deck? How do I, in the Spinnaker UI, how would I go to this UI here, and how would I be able to add the stage type my stage, right? If I added a new stage, how do I get it to register in this list? Which is a great question to have, right? So obviously it's here, it's configured correctly. How did we do that? So let's go ahead and open up this pipeline modules file, and this is a huge file, right? But this is kind of like the main where everything is going to be imported. All of the stages are going to be imported into this file, and then through the Deck build process, it's going to make sure that this is exposed properly, so that when you, by the time you, the user, get to this point, you have your stages configured. So once we've defined all of our stages, all we have to do to enable it or turn it on is to go ahead and import that file here. We don't have that nice Spring Boot framework that's just going to allow us to add an annotation and have it automatically registered. We're going to have to add this import here. So go ahead and maybe do that as a first step. And then we're going to go look at the individual files that we're modifying here. So I'm going to go ahead and open up the directory. And let's talk about the anatomy of a stage. So let's talk at the highest level at what a stage looks like in Deck. So a stage is composed of these keys here. So you have a label. This label is what's going to show up in the deck UI when you go ahead and run the application. So I've got deck running here, and I will explain this command in a moment. But essentially what's happening here is this yarn command is going to watch my project for changes. And at any time I make a change, let's say we want to change this to my stage now with more staginess, right? When I go ahead and save this, you'll notice that this yarn command immediately picked up that change, and it's going to go ahead and recompile everything. So I'm going to go ahead and leave this page. That yarn command will also make sure to update, or sorry, automatically refresh the page here. So now if I go and look for my stage, we can see it's now my stage, now with more staginess. So this label is going to modify or control the label that is shown in the UI. Next, we're going to have a description. So this description we can see maps to this stage. Doesn't do much, but we can at least see our stage. We're going to give it a key. This key is very important. I want to spend a little bit of time here because when we look at our Orca code, and it looks like Orca is successfully running again, so that's good, perfect. My special stage here, this is a very intentional naming convention between this key here and my special stage defined in our Orca codebase. So essentially, in order for the deck stage to correctly identify the stage in Orca, we need to provide a camel-cased version of the stage without stage. So you might have a natural inclination to say my special stage, because of course the class name in Orca has stage at the end of the file. That's not, we want to resist that urge and resist that temptation. We just want to have my special, because when we make that API call, or when Deck makes that API call on our behalf, that is how it's going to identify the stage. So make sure if you've made any modifications to the code base in Orca, make sure that at the very least you match up this key. Everything else can be local to Deck. It can be whatever change you want. It doesn't have to map to the Orca code base, but this is really kind of the keystone for making sure that Deck and Orca are communicating appropriately. All right. So then the next question you probably have is, if I go to the browser and I go ahead and try and edit my stagey stage, you'll notice that there's no configuration options here, right? There's absolutely nothing for us to configure. Unfortunately, given the state that we're at in the workshop, we're not going to have a ton of time to dig into how you would add configuration options, but know that you would implement my stage config, right? Or whatever you want to call this stage. And I will actually make the split this way. And so long as your React class for my stage config extends a React component that accepts stage config props, then you can define your own options here. So for example, what we can do here is we can add a little message here in this render component. And again, we'll see Yarn dutifully going back and compiling all of our code. When we come back to Spinnaker, we can go ahead and accept that we will leave the page. And now we can see if we modify my stage, we see this change here. So what the heck just happened? I'm a platform developer. I don't understand this JavaScript business. What do I need to do in order to get this working? Let's quickly talk about React components here. So this isn't going to be a comprehensive tutorial, but this is going to walk through kind of the basics that you would do if you were going to modify a stage or update a stage for yourself. So you have this class definition here. So far, so good. If we're coming from Java land, extends, yeah, very similar to implements, and we're going to pass in a class. In this case, we're just going to accept all of the stage config properties that we accept for any stage in Spinnaker, right? So we're going to import that from the common stage definitions in Deck. We're going to define a constructor, and we're just going to delegate to our parent. We don't really have anything specific to do here, so we'll just trust the wisdom of our parents. And then you're going to have this component did mount method. And this is kind of a special method in React that's going to allow you to take some action once your component has been mounted. So again, React is kind of this declarative-ish framework for defining all of these components that you can have inside of a web page. So component did mount is kind of your main method for determining when you can actually do some useful work. And then finally, we have the special render function. And if you're really out of touch with the front-end world, this is going to throw you for a loop, because this looks like HTML defined inside of a JavaScript file. So if we look at the file that we're in here at the top, we have this funny extension here called .tsx. TSX is considered a TypeScript, and I might say this incorrectly, but a TypeScript extension file or a TypeScript with JSX file. I think that is more correct. And basically, that's the combination of TypeScript, which allows us to have this syntax here where we can declare different classes, for example, and then JSX. And JSX is this extension language that allows us to embed HTML-like syntax inside of a JavaScript file or a TypeScript file in this case. So just by nature of giving this the right extension and having your editor configured to recognize JSX, which all of the major editors support at this time, you can actually embed your syntax here, right? So that's a very, very high level of what this stage config looks like. And then finally, if we go back to our stage configuration, we have a few more things to talk about. So we have our execution details section. So execution details and execution detail tasks, these correspond when we go look at our pipeline execution. These classes correspond to my stage status here on the left. So this left-hand task is defined by the execution details task. So this is where you can provide contextual information to your users about what's going on the back end, what's going on when your pipeline is running. And then task status is a fairly straightforward implementation describing how you return information about all of the different tasks that are registered for your Orca stage. Okay. One other thing that we can briefly touch on is you can define validators. We're not going to dig into validators too much, but basically this is where you would provide validation for your configuration options. So if I actually had some form inputs here in my stagey stage, these validators would make sure that those values were actually being populated correctly. And then if I made a modification to this stage, you know, maybe we change the name here or something, this, whenever we click on this Save Changes button, and let me go ahead and remove this. There we go. Whenever we click on this Save Changes button, all of those validators are going to be called in sequence. So if you fail a validation here, for example, if I only ever want to say goodbye, I never want to say hello, I can write a validator to validate that behavior. And when I click on Save Changes, it would actually prevent the pipeline from being saved. So your incorrect configuration could not be committed to Spinnaker. So that's where you would do your validations. So finally, let's look at the last piece here, our stage execution details. So this is where we would provide, here's my stage status. So this title is what is being controlled here in our overview. Yeah, it's okay, don't worry, don't worry. Okay, this my stage status, this is what is modifying this title here. And then we're just rendering information based on this execution details section. So this is another piece of JavaScript or TypeScript loveliness, where as part of this JSX extension, we can actually refer to other React components within our render statement. So we can grab stage name and current values as well as outputs from the properties that are passed in to our stage and, or sorry, to our UI component here. And then we can get the outputs that are coming from our stage. So all of this information, by nature of extending this execution details properties and calling our parent constructor and accepting the wisdom of our parents here, we get access to all of these values coming from Orca. And my best advice, if you're not an experienced JavaScript developer, is to look at other classes inside of the deck code base so you can kind of get an idea for what's possible and what's not possible. So what we'll do here is we'll call this React component, which is kind of encapsulating the standard display, if you will, for all of this information. And then the only thing we're going to do here is we're going to look at the outputs. So I'm going to refer back to our task here and refer to our outputs variable. So we have our stage start status. And you can see here, we're going to look at the outputs stage start status. And if that value is provided in the outputs, we're going to define it. So here is our value start. That maps to the value start here. And we're going to provide the value of that message. So if, for example, we had a little bit more time, we could change this value to something else. And then when we go ahead and run this pipeline again, we will see this message, something else, show up. So This has been an absolute deluge of information. I'm sure your head is spinning at this point. I'll reiterate my message from the beginning. If you walk away not understanding 100% of this workshop, it just means you're human. And so again, I'll refer you back to a previous version of this workshop where we walked through a simplified version of what we talked about today. I'm sure the recording for this session will be made available at some point in the future. We'll go ahead and update the page here. But hopefully that gave you a good sense of kind of what it takes to get your environment set up, make a change to a backend service, make a change to a front-end service, and kind of see that all running together here. So I'm going to reserve these last 5 minutes here. Let's just kind of open it up. Any general questions, either about the workshop or about Spinnaker or about the operator, kind of open-ended, whatever you folks want to talk about. All right, so we have a question here from Sudo around how do I manage Spinnaker installations using Ansible? That would really depend on the kind of approach that you want to take. So if we refer back to our diagram here, yeah, so we used to use Halyard, but Customize seems very interesting. So Customize itself is not tied to the operator, but Customize is tied to resources that are typically managed by Kubernetes. So what you might end up running into is that you'll still use the operator under the hood, but you'll use Customize as kind of a higher level kind of manifest management system. And then Ansible would kind of be modifying all of these, would be applying and making sure that these changes are in sync with your cluster. So you can think of it kind of like as the operator managing the cluster itself, and then Ansible could be managing the operator config itself. And your cluster configuration. That would be one way to do it. There's also, I think, a Helm chart available for Spinnaker. So if you're not super tied to Ansible, you could also explore the Helm chart. And the Helm chart is also basically going to execute Halyard commands under the hood. And it's going to do so by actually running a container inside of the Kubernetes cluster to spin up Halyard and execute Halyard commands that way. Although I am personally less familiar with the Helm chart approach. If you'll permit a small plug, I think in week 4 of this conference, my product manager, Akshay Dayal, and I will be talking about how to manage operator configs using Spinnaker itself. Yeah, so that kind of gives you like a broad range, choose your own adventure of how you want to manage all this stuff. All right, so we only have a few minutes left here. I want to thank everyone for joining me today, for following along, for kind of humoring a lot of the information that we've conveyed to you today. I'm hoping that this gives you a really good sense of how you can develop against Spinnaker, kind of demystify a lot of what this diagram is showing you. And yeah, I hope this was really useful for you all. If you are so inclined, feel free to leave feedback. I'm not sure what the best medium to do so would be, but you can also send feedback directly to me if you like. I've got a thick skin. If you want to tell me the content was too fast or too much, or you know you enjoyed this, please do let me know. That helps us ensure that the content going forward is the most useful to the broadest set of folks. So again, thank you. This is week 1, so enjoy the next 3 weeks, and I hope to see you around on Slack. So thank you, everyone, and have a good rest of your afternoon or evening.